Hello, students of the statistics class. This is Dr. Tausman. This is the recording for information right before the exam. Sorry about that. I've never sneezed on tape before. Don't know how long this is going to be. I don't think it's going to be terribly long, but a lot of little important lessons for you that I hope will be useful for you and will certainly be on the exam. You can send me drafts and questions about any of this as you wish. I would expect that you would take the one-page outline that we have and type up basically notes for this. Starting with number 1, the asthma abstract. You can or cannot have the asthma abstract on the notes and information you send me. It describes the asthma self-management research that I typically do, and it's kind of a concise version of an abstract that we wrote. But let's actually start off with an issue. I'll assume that you can read the abstract. The question that I think I posed even in our last week's class is, I tried to develop an asthma self-management program, and the question is, would this actually help people with their quality of life and other behaviors that might help their asthma? So the first question that the abstract might raise is in terms of how I designed my study. Do you think I designed my study if I wanted to see the impact of my program as a between subjects design and a between subjects t-test, or a within subject design? Hopefully, as you read the abstract, you see that I actually ended up doing within subject design and paired sample t-tests. The reason for this, there were 2 major reasons, and you should know these. Number 1, if I'm trying to recruit people for my study, then it's a lot easier to recruit less people, because a paired sample t-test or a within sample t-test, within subject, same thing, basically means I only need to have half the people I would need to in a between subjects design. And the other, and more important thing is a within subject design allows me to remove individual differences. So if somebody comes into my study and they have a low quality of life, somebody else comes into my study and they have a little higher quality of life, that won't matter, because it'll be so. As we said, a within subject test removes the individual differences, and it also, you need less people. So that's why I chose a within subject design, so you can know that about the asthma abstract. Next, moving down to Roman numeral 2, you should know that in this particular study I found a good scale to evaluate my asthma program. It was called the Asthma Quality of Life Scale. It was a 4-point scale with a higher number basically meaning people are doing better. And if you read on 2A, according to previous asthma research has actually shown that if people improve by more than 0.5 as a group, that means whatever you're designing for your asthma intervention program is really helping people with asthma. So, for example, if people come into the study, if I have 10 people and the mean on the 4-point scale before the study for these 10 people is 3, and then after the study the mean is 3.51, then the treatment effect would be 0.51. So if you get a treatment effect more than 0.5, research has shown, that means you've really done something to really help out. So that would mean you've done something of clinical significance here. So let's actually take a little look at the table there and see what we've got. One thing that you could note is I actually have 2 tables that look kind of similar here. And that was done for a particular reason. In this particular example, you'll notice that I have quality of life table for year 1, where there were 10 people in the study. And then notice table 2 has quality of life, but for that study, I kind of combined year 1 and year 2. And once again, quality of life is just how is your asthma quality of life. If you look on the left margin, you can see the dependent subscales, the dependent variables. There were 4 of them. They're actually described a bit in the abstract. One of them is activities. So a treatment effect that is higher says that people get better with their activities after our program. Symptoms, a higher number means better with the symptoms. Emotion means you're better at handling your emotions related to asthma, and environment means you're better at controlling your environment. Don't worry about the negative versus positive, because it doesn't really matter which number you take first. The treatment effect, if you remember, we want the treatment effect to be as large as possible. Do you remember where that goes on the t-test? That goes on the numerator. So the numerator has the treatment effect, and you can see out of the 4 groups, which one actually has the largest treatment effect. Well, if you look at it carefully, it looks like activities. People on average got 0.83 better after the program. Now, if you look at all of those, do all those treatment effects look pretty good? Hopefully you would answer yes to that, because according to 2A, previous research has indicated any treatment effect greater than 0.5 means my program really worked, that it was clinically significant, and that's certainly what we want to be. So it looks like all 4 of those are clinically significant. But then go to the final column there. You can see a t-score was computed, but if you go to the final column there, does it look like any of those results are significant? Well, hopefully you figured out that in order to be significant, your probability had to be less than 0.05. So none of those results are actually significant. So that's not necessarily a good thing. The question is, what's going on here? How come we have such a large treatment effect in the numerator and we are not significant? Well, the probable situation here has to do with the difference between table 1 and table 2. If you look at table number 1, notice how many people there were in this program in the first year. There were only 10 people. Take a look down at table 2, where I actually combine year 1 and year 2. How did the treatment effects look for that one? Well, if you look at the treatment effects when now I have 20 people, the treatment effects are kind of similar, maybe a little stronger for some of these, but kind of similar. But now, look what has occurred with the probabilities. Now, all of a sudden, everything is statistically significant. So the question is, what is going on here? It seems that doubling the sample size really helped. And that goes into the issue that is labeled D here, power. The problem that we had for table 1 in year 1 of the study is that we didn't have enough power in our study. Power is the ability to detect significant differences. We know the treatment effect is really large. The program has clinical significance, but it doesn't have statistical significance. So for each one of these, we would not have a statistically significant result here. And that is indeed a problem. We probably have a statistical error going on. It's often called a type 2 error or miss. A miss basically says, and when you make statistical decisions, if you had to write the statistical statements out for table 1, you would have to write out p greater than 0.05 for all of them. And that would probably mean t parentheses 9 for activities, 1.83, and then p greater than 0.05, and then it would follow suit for the 3 other ones as well. T of 9, 1.48 equals p, p greater than 0.05. Same thing for the third one, and then the same thing for the fourth one. So none of these would be classified as significant. So if I concluded here, on the basis of the statistics, that, hey, I don't think my program worked here, would that actually be correct? Would it be correct if I just went on the basis of the statistics and said, look, none of the statistical significance, it's not significant, therefore I don't think my program worked? The answer to that question would be probably not, that I would have made a statistical error. It's called a type 2 error or miss. You've got to be very careful when you've got a really strong treatment effect, yet statistically it's not significant. So we probably have, for year 1, a situation where we have clinical significance but not statistical significance, and we probably have this type of statistical error called a type 2 error, which is a miss. There was a treatment effect. My program really did work, but I just wasn't able to detect it. I missed it. So if you need to listen to this again, hopefully you can. Let me move down into table 2, which will hopefully validate this a little bit more. For table 2, hopefully what you can see is that when I combine year 1 and year 2, now I have more power. So I have more ability to detect significant differences. When I combine that, I have more power, and by having more power, now all the treatment effects are turning statistically significant. Why is that the case? Well, if you remember, in the numerator you have the treatment effect. The denominator is called the standard error of the mean, and remember it's related to the standard deviation. And if you look in the standard deviation in table 2, the standard deviation is lower in most of those cases, and so that's why we end up being significant. The sample size helps make things significant because we have more power. So hopefully that makes sense to you. Hopefully you can write out the T statements showing non-significance there, and you understand this issue of clinical significance, type 2 errors, and power. Thanks.